Usually when two variables are somewhat related to each other, we tend to describe them in a function. And one of those functions is a linear function, where its graph is just a straight line, as shown right here. And the concept of proportionality, as you will see, is very similar to linear functions, which we will see right later. Now, there are two types of proportionality: direct proportion and inverse proportion. So I just talk first about direct proportion. We say that a variable y is directly proportional. This is the symbol for proportionality. So we say y is directly proportional to x if y and x satisfy the following equation. So if y is equal to k times x for some constant k, keep in mind that k can be a constant, so it must be fixed. Or some may define that as y over x must be a constant. Or in other words, the expression y divided by x must be always equal, no matter what values y and x are. If any of you are familiar with linear functions, you know that this equation resembles a graph of a line passing to the origin with slope of k. Now let me just demonstrate a use of direct proportion in our real life. So one of them is when you're buying things, for example, pizza. So assume that you're buying pizza on a restaurant which costs $10 per pizza. What's the cost if you buy one pizza? Well, that will be $10, that's pretty obvious. And what happens if you buy two pizzas? That will be $20. Same thing with 3, 4, and 5 pizzas, you get $30, $40, and $50 respectively. Now notice something right here. Notice that the cost is always 10 times the number of pizzas that you've bought, which can be described if we set our cost to be y and the number of pizzas that we buy to be x. This can be described as the relation y is equal to 10x, which fits in with the equation for direct proportionality. So what we can say here is that the total cost right here is directly proportional to the number of pizzas that we bought. Now for inverse proportions, we said that a variable y is inversely proportional to 1 over x if it satisfies the following equation. We have y is equal to k over x for some constant k, or some may define it as x times y is a constant, no matter what values of x and y is. Now the graph of our equation y equals k over x looks something like this. So it looks like a curve right here. Now an example of inverse proportion in our daily life is how the number of workers is related to the time taken to complete a certain work or a project. So let's just say that 2 workers require 10 days to complete a certain project. What happens if we multiply the number of workers by 2 so that we have 4 workers? Well, we expect the time to be twice as faster, or it will be just 5 days. And similarly, if we decided to reduce the number of workers to 1, or we decide to divide the workers by 2 to get 1 worker, then the time will be twice as long. That will be 20 days. So notice that how these two are related. Notice that if you take the product of the number of workers with the time for each corresponding row, you'll always get 20, which fits into our definition of inverse proportionality, with x times y being a constant of 20. Or in other words, y we can suppose as the time taken to complete that same project is equal to 20 over x. And by the way, we're assuming that all of these workers work at the same rate and they don't take breaks. Now before I end this video, I want to show something. Notice that the graph on the left resembles the graph of direct proportion, and the graph on the right represents the graph for inverse proportion. Notice that if you increase the value of x, or if you shift the x coordinate to the right, the y coordinate or the value of y will always increase. This can be seen for a fixed point P on the graph, and then you can see how y and x both increase and decrease as you shift this coordinate P to the left or to the right. Now notice that in the graph y equals k over x, if you increase the value of y, notice that y will decrease right here. So assume we have a fixed point P on the graph, and then if you move this to the right, notice that it also goes down, and vice versa. If you decrease the value of x, the value of y will increase. So it's always the other way around. And those are actually one of the most basic and important concepts of proportions, which ends this video.